Alright guys, so today we got a beautiful morning and I just got a service call in this school. So I just came up this roof right now through here. I'm gonna check this AAON package unit. They told me that the gym was not cooling on this school, so I went in there and just it's not cooling. So let's check it out and see what's going on. I do notice, I think I can hear the blower running. So let's see. Let's open this package over here. Let's see what's going on. Yes, I can see that the blower is running, but my compressors are not. I know this compressor is bad because I already came to this unit once. Hasn't been replaced because they haven't want to buy it. So if they don't want to buy it, and I cannot replace it. That one is, I think it's open. I even have it disconnected. And these units, it used to have controls. We call them DDC controls. But because they don't use those controls no more, and they didn't want to put new ones on them, I decided to put a thermostat. So I connected a thermostat to my return. We have a average or close approximity to the room space temperature from my return. So I have a thermostat, connected on my return. So I'm gonna start checking this out. I know I should have high voltage because my blower is running, and I know my blower is a 3-phase motor 460. And there's only one way to get that 460 to that disconnect on the fuses. Those fuses right there. And if I didn't have the 360 high voltage, then I wouldn't have my blower running. So I don't know what's keeping my compressor, because not even the condensers are running. Basically my contactors for my compressor and my condenser fan motors are not cooling. So I don't know if it has something to do with the thermostat. I'm gonna check it out. But I just wanted to touch some basics on troubleshooting. Like I said, the service call is that it wasn't cooling. So when you come up to a unit, you know, I always remember some words that this technician, when I was an apprentice, in my fan used him out. So something's going on. Now it kicked back on. I don't know what's going on. I'm gonna have to check that out. I don't know if there's something loose that is making that happen, or my thermostat is acting weird. I don't know what's going on, because my blower just came off and then kicked back on. So my point is, when I was an apprentice, there was a technician that he was really nice. He taught me a lot. He had patience with me. And the first thing I remember he told me when I first walked into a mechanical room, he said, this field HVAC is nothing but common sense. That's what he told me. So if you have common sense, you won't have that much of an issue. So it's like here. I'm not saying, and don't get me wrong, it's always good to check everything anyways. But as you can see, my blower went out, turned off, and then back on. So that makes me think that there has to be something wrong with the control voltage. So my main focus here is going to be the control voltage. So that's common sense. Why? I'm still going to check just to verify, just to make sure, but I'm pretty sure I don't have anything wrong with it, with my high voltage, because my blower is running. So I'm not gonna have my main focus on the high voltage, you know, especially after I verify that those fuses are good. You never know, it could be, I don't think so, because when it goes on single phase, you're gonna have issues. The blower issue is not gonna be running. It might burn up. Sometimes it might turn slowly. But anyways, like I said, my blower seems to be working good. I'm gonna open the door for my blower. So my main focus is gonna be the control voltage or low voltage. Here I think it's 120, my low, if you want to call it low voltage or control voltage. So I'm gonna see why I'm not getting, why my contactors for my compressor and my condenser fan motors are not pulling in. So they're not pulling, they're not made in. If you can see there it goes again, my fan kicks on and off. So definitely I have something going on my control voltage. So that's common sense. I'm not gonna go check refrigerant right now, because I'm not having issues with that so far that I know. I'm not gonna be looking into problems on my high voltage, because I do have high voltage. So you start eliminating stuff when you troubleshoot. And now I'm gonna be focusing on my control voltage. So that's common sense, and that's what I'm trying to tell you in this video. Troubleshooting HVAC is nothing but common sense. Once you start learning the systems, you know, all you gotta bring up is common sense to you, and that's gonna help you a lot. So let me check it out. Give me some time to see what's going on in the control voltage, and then I'll keep you updated on this video. All right, so here, this is where I am so far. I shut the power off so there's less noise. Kind of already trace what issue I'm having. Like I said, common sense. I start looking into my control voltage and nothing else. I wanted to see why those contactors are not being made, and why my fan keeps cutting on and off. So I checked my thermostat. My thermostat is doing its thing. I never lose 24 volts from the thermostat, but I do lose it at the contactor. Like I said, common sense. I didn't put my main focus on the high voltage or low voltage, because that's not my issue. I still just double check and check for 460. You know, if you're new in the field, first of all, when you walk into a unit, you gotta realize what kind of voltage you get. So on this unit, usually you'll get them on the name tag. On this unit, we get 460 on the low side or high voltage, and then from there you can go, if you don't have a manual, you can go to your transformers and see what kind of voltage you're getting to your control voltage. In this case, I'm getting actually 24 volts, as you can see on the transformer right there. So if you're new in the field, you don't know how to check the voltage yet, make sure you put your multimeter on voltage AC when you're looking into AC voltage. So what you're gonna do is, on a 3-phase 460 like this one, if you want to know if you haven't lost power from your disconnect, you know, you get your leads and you check. You can do two things. On a 460, usually you get around 277 on each leg, so you can either do this one to ground 277, this one to ground 277, this one to ground 277, or you can do it like this. This one to this one 460, this one to this one 460, or that one to that one 460. And then to check these fuses, if you have the power off, you know, you can check it with continuity right here. Now, if you're gonna do it that way, make sure your meter is set for that. You don't wanna check continuity when you have voltage right there. Okay, so what happened is, see right there's continuity, and it should do this beeping sound on your fuses. So you check from this one to this one, that one's good. This one to this one, that one's good. This one to this one, that one's good. Like I said, my power is completely down, so that's why I'm laying my hands kind of here, but always check your capacitors for any voltage anyways. You don't want to get shot with one of those. I've never done it. Hopefully it never happens. But if you're gonna check with voltage, the way you can do it is the same way you did it here, each leg to ground. So what you gotta do is you gotta realize where you're getting your voltage from. I'm getting the voltage from this side, so it should be on this side as well if my fuse is good. So what are we gonna do is leg to ground to 77, or this one to this one 460, this one to this one 460, and that one to that one 460. Or you can do it across as well, and you should read 0 to this 0, this to this 0, this to this 0. And that's how you know if your fuses are good or not. Same thing with small fuses, any kind of fuses. Anyways, so but I didn't put my main focus on that because I'm not having issues there. So I'm trying to trace my control voltage. So what I did is to trace it. Like I said, I cancel the control, the VDC controls. I have a thermostat. So my thermostat should feed 24 volts to any of these right here relays. So really important, especially in commercial, because it's a little more complicated. As you see all the wires that you have, that you learn to read these diagrams. Now sometimes the diagram is fade out and you're gonna have some bigger issues. In this case, thank God I have the diagram is not fade out. So what I did is I went to my diagram and I start reading what these little things are, everything here. So really important you learn how to read diagrams. That's gonna help you a lot. You have no idea how much that's gonna help you. And in this case, I still have everything labeled. As you can see, every little thing is labeled. So right here is another label. So that's my LVTV. And on my diagram, I have LVTV. So this is where my voltage is gonna feed each relay over here, contactors over here, low pressure safeties, low pressure switches, high pressure switches. So what I did is I went to, first of all, my Y1, which is my cooling, and I start tracing it, making sure I was having control voltage from here to here, from here to, trying to look through the phone, to here, from here to here, from all the pressure switches, the timing. So where I stopped getting voltage was actually here on the timer, the GOT1, right there. Now I went and looked for GOT1. That's how I found out I didn't have no power there. Right here, GOT1, this one right there. So what I did is, okay, I already checked my high pressure switches. I went like this, checking it, making sure I'm getting power. And on R1 I have 24 volts, but in Y1 I don't have 24 volts. So I'm not getting power to my contactor that is gonna feed my it's gonna make my compressor come on. So that timer, I want to know what makes that timer works. And I noticed, like I say, the fan is kicking on and off, and I have a timer right there, and I have a feeling it has to do with whatever is feeding my fan that is not making that timer kick on, because the fan keeps keeping on and off. So I went back and I started looking on my brown, which is my G, and was feeding my blower, and I noticed right here the power is cutting off, and that means this relay is losing power. So I went to what is feeding my relay, and I start tracing them right here, and I went to HGR3, you know, to see little by little what's feeding it. And I realized, where am I? The brown right here. And see what's feeding I'm trying to see, because I'm trying to see through the phone, so it's kind of harder for me to. Anyway, so I came up with right here this relay here is actually losing, is the one that is losing the power, that is not giving the power that I need for my blower. I'm trying to trace it right here. See this one right here, which is what's feeding this blower relay. So this line right here, this line right here, I keep losing the power right here. So that's the reason this one, the blower relay, keeps kicking on and off, because right here is normally closed. So when this one kicks on, it opens, and then when it gets power, when it loses power, it closes back again. So what I'm gonna do is I'm actually gonna replace this one, because from here to this one, that's where I'm losing power to. So I'm gonna replace this HGR1 that at the end of the day is feeding my blower relay, and I think my blower relay has something to do somehow in the wiring here. I saw that it has to do with this one right here, which is my time delay. I might be wrong. Right here, the GOT1, my time relay. I might be wrong, like I said, but I'm gonna see. I think my time relay has to do with my blower as well. So I'm gonna replace the GR1 because I think it's acting up. That's my relay. I have it right here. It's 24 volts. I went to the van and got it, and see where it goes from there. 24 volts relay. I'm gonna replace it, which is this one, if I'm not mistaken, and see what happens from there. And if that doesn't resolve my problem, I'm gonna jump some stuff up just to start eliminating some stuff. And I keep tracing the issue that I'm having. So I'm gonna come back with you with the update and see how it goes. Well, there you have it running. Finally figure it out. Took me good time to find it. They take probably like 2 to 3 hours. And actually I need to come back and check the signal on this thing, because I don't like the sound of that compressor. It sounds like it's starving. But I already figured out the electrical problem. So I'm gonna shut the unit off so I can do a little explanation. Let me shut the unit off. So okay, here I am. I replaced that relay that I told you that was not the problem. That's what I said. Maybe I was wrong. I tried that avenue, but that didn't work. But same thing, back to basics. I keep my eyes on the low voltage and the control voltage. I never went anywhere else but control voltage. And the way that I found the problem is going back to the diagram. So it's really important that you learn how to read diagrams, because that's going to help you a lot in these cases, especially in the electrical side. And if you work on commercial, as you can see, you have a lot of relays. And this is not as bad as other ones. You have a lot of wires, a lot of contactors. But once you start getting familiar with these units and with the diagrams, it's not that big of a deal. It's still a headache. It's always a challenge, at least for me. I don't know for the ones that have more experience, but to me, HVAC is always a challenge. No matter how many years you've been in the field, you just never know what you're gonna encounter. So what happened is, I start going the old-fashioned way too. So what do you mean the old-fashioned way? I start putting jumpers on some stuff. For example, the time delay. I put a jumper on the time delay. The reason, the way that I found this time delay, that it was from my compressor, is because I found it over here on the diagram. It's this one right here, GOT1. That's the time relay right there. So I was getting voltage all the way to there. So that means after that time delay, it comes to my contactor. So that's when I was like, okay, if I'm getting voltage all the way to my time delay, but as soon as it hit my contactor, it shuts off. So now I put my eyes on the contactor, and what I did is I disconnect the yellow wire that comes from my time delay. This was the contactor actually. This was the contactor. So I disconnect that yellow wire that I had in this contactor at first, and voila, that didn't happen again. I didn't have anything connected on this contactor. This is for the circuit 2, but because the compressor is bad and it's completely disconnected, so I put the yellow wire that comes from my time delay, I put it on this contactor, and it kicked in. It made in. So my problem is this contactor is bad, and I put ohms. I ohm it, and yes, the ohms are way lower than the ohms on all these contactors. On this one is like 999, and this one is like point something, 0.2. So definitely that contactor is bad. Then I had to change the jumper that is here to my condensers. I had to put it over here too. So basically I put my compressor system 1 on the contactor for circuit 2, but I'm controlling it with the same controls from circuit 1. See, this is my control voltage for system 2. So that's what I did, because I don't have a contactor with me, first of all, and I'm on the roof, and they need cooling. It's already like 10 something in the morning, and it's pretty hot here in Texas. So what I did, I just put my load from my compressor. I put it on this contactor right here, and now it's running. My condensers right here run pretty good. So this one is bad. I'm gonna mark it bad, and I have to come back and replace this one. I haven't replaced that compressor again because they don't buy it for me. And that's how it is in the district sometimes. In school districts, they have budgets, and if they know that that gym is cooling, that's all they care about. But anyways, I'm gonna beg them to give me that this compressor so we can replace it. The bad thing is we don't have the equipment to put it on the roof, so they might get contractors for this. I don't mind doing it, but like I said, here in the district, it's another story. Anyways, so again, I'm gonna come back and replace this contactor, and then I'm gonna put my gauges, because I don't like the sound of this. I didn't see that much of bubbles on the side glass, but you just never know. I'm gonna bring my gauges and just check the freon on this unit. But this is how you do it. This is the basics of troubleshooting, common sense. If you're new, you have to really learn how electricity works, first of all, and second of all, if you want to be a good technician, if you want to be able to troubleshoot the electrical problems on the unit, it's really important that you learn how to read the diagrams. I might make a video later about basics of reading diagrams. I'm not a teacher, so it's not gonna be super smart, but just basics. You know, like in school they're gonna teach you how to read all these signs, like that's the coil for the resistors, or a coil for the transformer. Same thing on the relays right here, normally open, normally closed, and all those little things they're gonna teach you in school. So you gotta learn those. You get familiar with them. So you get familiar with them, and things are gonna get a little easier for you. But I'll make another video about diagrams, basics of diagrams, on another occasion. But this was my problem. The contactor was bad right there. Usually when that happens, those little 3.2 amps breakers popped out, and that's how you know you got something grounded or overamping on these contactors. And that's really common in these units. As you can see, there's several contactors there that some people left there, and they're bad as well. But that's it. And without being said, I hope you like this video. Please like and subscribe to support this channel, and I hope you guys have a nice day. To me, it's a weekend, so if it's a weekend for you, I hope you have a nice and blessed weekend.